Okay, so we would like to see the graph example. There is one class graph. So it is a quote from the chapter 14. So if you have the book that I recommend you for this course, it is a book about the data structure and algorithms in Python. So the authors of the book, they provide the code, and this is the code about the graph. And I think I already explained a little bit about the graph. In the graph, we have two classes. The first is vertex, and the other is edge. And then there are some basic function like the constructor. And then we want to get the element. And then this is just to put the vertex ID in the term of hash. And we want to know what is the value of that particular vertex. And we have the edge. So we can get the constructor. So the constructor here contains of three components. So we can see here, U is the origin, V is the destination, and X is the element. So do you know what is the meaning by element? Yeah. In the example that we have in the graph, if you take a look on this graph, so the element of the X, it can be the cost, okay? Or it can be the mileage between two nodes, okay? Or maybe it is the distance between the two nodes. So there can be the information about the element. We want to find the endpoints. So we learn about the graph, about the endpoint, the opposite. And then we want to find what is the element of this edge. And then we can put the edge in particular storage using the hash. And yeah, we can print what is the origin, what is the destination, and what is the element. In the graph methods, we can construct the graph, and then we can verify, we can validate. So what is the validate? So we want to find out whether the vertex is belong to this graph or not. So verify that V is a vertex of this graph. So if V is in the graph, then yeah, we can give the information about the V. But if V does not exist, then we can just give the message vertex does not belong to this graph. Is directed. So we are having the concept about directed graph. So directed graph is something we have the direction. So we have one node, we have another node, and we have direction. But undirected means two nodes will have connection with other node regardless the direction. Vertex count. So how many vertex do we have in the graph? Vertices. So we want to find the outgoing. So we know the outgoing and incoming. Okay. So if it is like this one, then we can say this one is there is an incoming X and there is an outgoing. So outgoing it is out and incoming it is come. Okay. And the number of X can be counted. And then the edges means we want to find out how many edges in the graph, and we want to find a particular edge. For example, I want to find the edge of u comma v, so I can get the particular edge. The degree, so I can calculate what is the degree of a vertex. So we can see if we have a vertex like this one. So the degree of vertex, if this vertex, then the degree is 3. What about this? The degree is 1, because only one adds to this vertex. So we can calculate the degree based on the number of edges entering that vertex. Incident edges. So we know that we want to know what are the edges incident to a particular vertex. And then insert vertex, and then insert edge. So those are the basic functions or the basic methods that you can do in the graph. So there are some ways to deal with the graph. For example, if I want to make a kind of graph, so let me just run this one. So there's one code about the graph example in the chapter 14 in the book. It is using the graph from the edge list. Okay. So we have some, if you take a look on the graph, okay, so we have some data structure, for example, the edge list structure. And then we have the adjacency list structure. And we have the matrix structure. So in this code, I would like to use the edge list. So how we can do with the edge list? First, we will make the G. G is an object of a graph, and I would like to make it as a directed. So the first is the original or the default value is false, but we can change to true if we think that we want to make a graph which is a directed. P is a set, so it means it should be unique. And then for every E, we want to add the E at 0 and then E1 into the V. And then we can have a kind of dictionary, or we know it as map. And then for every V, we want to insert a vertex into this list. And then also we want to insert the V into a particular, so it is in the graph. So we want to insert, the vertex source and the vertex destination and the element. So we use this insert vertex and we use the insert edge. So we use the insert vertex and we use the insert edge. So this is one example. I generated this simple example, and this is the example from the figure 14-3 in the book. So if you want to take a look, I already put one PowerPoint in the e-class. So there's one PowerPoint about graph example. So in the graph example, you can take a look. So if you have this graph, okay, so how many vertex do you have? How many vertex do we have? if this graph shows a network of transportation among cities in Korea. So let's assume that the node represents the cities. So how many vertex do we have? 5. Okay, thank you. So we have 1, 2, 3, 4, 5. Okay. And every X represents the availability of the transport. So let's say we have the X from Seoul to Daejeon. Okay, now we can see the X is shown as a directed graph. Then we note that there is a transport from Seoul to Daejeon because there is a direction. And then from Daejeon, there is a direction to Busan, and there's a incoming to Daejeon from Busan. And if we want to return back to Seoul, we cannot go back to Seoul directly, but we need to go to Suwon and then go back to Seoul based on this direction. And if we want to visit Gwangju, then there is a directed graph or there is available transport from Seoul to Gwangju. But if we want to return back to Seoul, we need to go to Suwon to return back to Seoul. So that's the meaning of this directed graph. The second example, which is the figure 14.3. So it is about the network of airport in the United States. So you already see some of the examples before in the PowerPoint. So we have the SFO is the San Francisco, LAX is the Los Angeles, ORD is O'Hare, Chicago, and so on. So this is the network. So there is a trip or there is a route from Boston to San Francisco. And then there is a route from JFK, John F. Kennedy to San Francisco, and so on. So we want to use this information and how can we fit it into the graph code that we have. And this is the example from the figure 1414. So the graph is more on the map. So we can see this is the airport as well. And then we can see the location of San Francisco is here. Los Angeles is here. So we can see not only the graph. So if the figure 14.3, it just shows the network. But in the 14.14, it shows the distance or the mileage between the node. So using this information, you can take a look on the Jupyter Lab. So the simple example can be seen like this one. So the E, what is E? E is the X. Okay. So we have the X from Seoul to Daejeon. And then we have the X from Daejeon to Busan. We have the X from Busan to Daejeon. We have the Daejeon to Suwon. And then Suwon to Seoul. And then Seoul to Gwangju. Gwangju to Suwon. Okay. And if we have this X list, we call it this is X list. So we want to create a graph. We want to insert the E. E is this one. So it is a tuple. And then we said this is true. What does it mean? So the E is the X list. So the data structure here, we are using the tuple from Python. And the true means we want to use the directed. So the original of this function or the default of this function is using directed equals to false. But based on the graph, I would like to make this as the directed graph. So I change this into true. Okay. So this is the function of the simple example. How about the function in the figure 14 under part 3? So the figure is here. So you can take a look on this graph, and it is the list structure based on that figure. So I can just run this one. Okay, let me run. So after I run this, I would like to call the graph Korea. The graph Korea is a variable, and it is based on a simple example. What is simple example? This one. Okay. We have this method or this function, and once we call this function, we will run this list e comma true, so we will generate the graph. After we have the graph, I would like to know the incoming. What is the incoming? The incoming here is anything from the graph Korea and put it the incoming. Okay, get data from the incoming, so there can be also outgoing. So if you check from this, if you check from this one, we can see the outgoing and incoming. So when you generate your graph, it will generate the attribute incoming and outgoing. So I would like to find the incoming. So here I would like to get the data from the incoming and put the data into a dictionary. So I hope you can review a little bit about the code from what we learned before the mid exam. Okay. The dictionary means if I have a kind of tuple, or if I have list and I want to create a dictionary, so I can use this way. So I run this simple example, and then I would like to find the incoming. So if I run this incoming, then okay, let's say Busan, and then I would like to find the incoming items. So every incoming from Busan, incoming to Busan. So I would like to check. Okay, the incoming to Busan is from Daejeon. And then what about Daejeon? Okay, the incoming to Daejeon is from Seoul and Busan. So we can see in the graph example, from Daejeon, there are two incoming from Seoul, that is the first, and then the other is from Busan. What about Seoul? The incoming to Seoul is from Suwon. The incoming to Seoul is from Suwon. And then Gwangju. The incoming to Gwangju is from Seoul. The incoming to Gwangju is from Seoul. And then Suwon. The incoming to Suwon is from Daejeon and Gwangju. So you can see the incoming to Suwon is from Daejeon and Gwangju. Okay. What about the outgoing? So the same way, if you want to check the outgoing, then it means the opposite one. If I want to find the outgoing Busan, okay. So the outgoing of Busan, so Busan has one outgoing to Daejeon. What about Daejeon? Yeah, Daejeon has an outgoing to Busan and Suwon. Daejeon there's an outgoing to Busan and Suwon. What about Seoul? Yeah, Seoul there's an outgoing to Daejeon and Gwangju. There's an outgoing to Daejeon and Gwangju. Gwangju there's an outgoing to Suwon. Suwon there's an outgoing to Seoul. Okay, so this is how we can represent the incoming and outgoing. If we use the figure 14-3, okay, so you can also do the same, but maybe it is more complex. So yeah, you can figure out by yourself. So this is the result, and this is the outgoing. Okay. Now, I would like to give you one more example before we do the quiz. So this is the example for 14 to the 14, and this adds contain the element. So for example, this San Francisco to Los Angeles, the distance is 337. Okay, so from San Francisco to Los Angeles, LAX, there is a distance of 337. So we can make the data like this one. The first X is SFO to LAX with the distance 337. There is another trip, SFO to Boston with the distance 2704, and so on. After we have this data, so we can create the X. So we can create the X, and the directed equals to false. So it is not a directed graph because the distance between San Francisco and Los Angeles, yeah, they are both same. So there is no direction. And you can generate this one, and then again you can find the incoming. Now the incoming will contain the distance information. So we have the distance information. Okay, this is about the depth first search. This is the quote from the book about the depth first search. I think we already learned, so you already got the video lecture about this one. So G is the graph, U is the node or the vertex, and then discover means every of the node that has been discovered. And then we want to construct the path. So construct the path, we want to find whether we already visit every of the node or not. And then we want to know whether it is completed or not. So we want to find whether we return a forest or a tree. Okay. So if you run this one, and then I would like to use the DFS complete. So I would like to find all the tree. Okay. So yeah, this is the tree from the graph Korea, which is the simple graph. Okay. Okay, I think I will explain this more on Wednesday, okay? Because you need to prepare about the quiz. So